I'm Russell Lindsay, product manager of our MS2760A ultra portable spectrum analyzer. We're going to do a quick demo of an auto radar signal. So we have our spectrum analyzer set up here with the software running on the PC. We have a TI-1642 radar module transmitting an Fmcw signal. And this is our control software for the radar. So what we have is we have a signal that's producing a 76 to 77 gigahertz signal. This signal is at a 20 frames per second rate, which gives us a chirp profile that starts at 76 gigahertz and has a frame period of 50 seconds. So we're going to look at if we center our frequency of our spectrum analyzer to the 76.5 gigahertz, and then we do a zero span measurement. It'll take a second for the FPGA to change images. As soon as that's ready, what we're going to see is we're going to start seeing the chirps that are coming through that signal. Okay, so here are our chirps. One thing I'm going to do just to raise the level a bit is I'm going to give that a turn on our IF gain. Okay, so now we can see our chirps. We're going to lower our sweep speed. So I said that we were at 10 frames per second, which means that we're at a 50 millisecond frame period. So if we set our sweep time to be 100 milliseconds, sweep time to be 100 milliseconds, that gives us enough room to see two chirps. Okay, and if I freeze that, get two chirps on, I can see that here's the distance of my chirp, the amount of time that my chirp is on, and here's the off period. And from here to here should match the frame period that we see here, 50 milliseconds. So if I put a marker at the beginning of the frame and a marker at the end of the frame, or at the end of the frame here, so from the start to the finish, marker table, it tells me that that is in X, that is 77 minus 27 milliseconds, which is 50 milliseconds, which matches the frame periodicity. Also, if I turn this back on, I can go into the sweep, and if I zoom in on that sweep, turn on my trigger. So I'm going to turn this as a video trigger, so I can trigger on that signal, and I'm going to set a delay -2 milliseconds to center that. So here's one chirp. Within this chirp here, I can see all of the different, within this period, the frame, I can see all of the different chirps within that frame. So I can count and see that if I count that out, there would be 32 peaks in there, which matches here. This says that I have 32 chirps per frame. Okay, so that 32 chirps per frame matches the 32 chirps we see in zero span. So I can count those and measure the distance and time between them. Okay, and then lastly, if I go back to my frequency domain and I change my span from a start frequency of 75.9 gigahertz. We're going to wait a second for that to load. Okay, so now we're in the frequency domain. I'm going to set the stop frequency to 77.1 gigahertz. So now I have a 1.2 gigahertz span, but I'm not seeing anything yet in the frequency domain. The reason for that is that we are using our high side, low side image rejection. We're actually losing the signal. So what we need to do is we need to increase the capture time to match the frame period, so that we're capturing a full period with both the high side and the low side sample. So if I come into my sweep menu and set my capture time to match that frame period of 50 milliseconds, it's going to slow down the signal, or slow down the sweep. But what you'll see is I'm now building out a full frame, or a full envelope of this Fmcw signal that's coming over into the analyzer. So that sweep should take about 40 seconds. So there you go. So that's a full suite of these signals. And if I take those markers and I put them at the edge of each of these signals, you see that I cover that full 1 gigahertz band from 76 gigahertz to 77 gigahertz.